वीडियो के थंबनेल से ये क्लियर तो हो ही गया होगा कि मैं इस वीडियो में सॉल्व करने जा रहा हूं एक कॉमनली आस्क्ड क्वेश्चन asked to me by many JEE aspirants. What is the remainder when 88C44 is divided by 89? यही सवाल मैं फैकल्टी रिक्रूटमेंट इंटरव्यू में भी लोगों से पूछता हूं, पर आपको जान के ये हैरानी होगी कि 99% टीचर्स भी इस सवाल को सॉल्व नहीं कर पाते। पर सच्चाई ये है दोस्तों कि इस प्रॉब्लम को सॉल्व करने के कई तरीके हैं, पर क्योंकि जेई वाले बच्चों ने मुझसे ये सवाल पूछा है, मैं इसको पहले जेई वाले मेथड से सॉल्व करके दिखाऊंगा और फिर एक ओलंपियाड वाले तरीके से भी इस प्रॉब्लम को सॉल्व करके दिखाऊंगा। तो पहले इस प्रॉब्लम को थोड़ा एनालाइज करके जनरलाइज कर देते हैं। अगर आप यहां पे देखोगे तो 89 इज अ प्राइम नंबर, सो लेट्स मेक अ फ्रेश प्रॉब्लम स्टेटमेंट हियर। इफ p is a prime number, then what is the remainder when p minus 1 ck is divided by p? Of course, here k is less than p minus 1. तो चलिए दोस्तों सबसे पहले देखते हैं जेई वाला मेथड जिसको हम कहेंगे द कॉम्बिनेटोरियल मेथड। सो लेट्स स्टार्ट विद द फर्स्ट मेथड व्हिच इज कॉल्ड द कॉम्बिनेटोरियल मेथड। So in this method we'll try to use our basic ideas of JEE, like how we have learned in our permutation combination chapter, to solve this question. See, students, 88C44, this number is actually too big to be evaluated, right? So obviously we cannot find the value of 88C44 and divide it by 89 to find the remainder. That is next to impossible to solve this question. So what I'll show you is a very interesting method, but yet ignored by many of the students. So let's see this method. So in this method, let's write down what is our expansion of p minus 1 ck. Okay. So we all know that this is going to be p minus 1 factorial by p minus 1 minus k factorial times k factorial. Right? Now, let's try to simplify a few things here. So we'll cancel out few of the terms from the numerator and denominator here. So p minus 1 factorial, we can write it till p minus 1, p minus 2, p minus 3, all the way till p minus k. Right? Why did I choose to write it till p minus k? Because after that, I'll get p minus k minus 1 and so on till 1, which is going to get cancelled with this term in the denominator. So I'm not writing that down just to save your and my time. And of course, we'll have k factorial left over there. Now, if you see on the numerator, you have a kind of a factor involving p. Like treat it like a polynomial which has been factorized. Here p could be treated like the variable x. So when you expand it, you get p to the power k, because they are k terms, plus you'll get some number p to the power k minus 1 plus some another number p to the power k minus 2, and this trend will continue till, let's say, p, and after that we are going to get a constant, and that constant will be the product of minus 1 minus 2 all the way till minus k. So can I write that as minus 1 to the power k factorial? Right? Of course. Then divided by k factorial throughout as how we have in the denominator, right? Now whatever term I have got, I will split this into two parts. One being p to the power k plus whatever we have all the way till p divided by k factorial. And of course we'll have minus 1 to the power k factorial divided by k factorial as well, right? So this k factorial and this k factorial will cancel out. Let's do that over here so that we are left with minus 1 to the power k. Now, we all know that any NCR kind of a number is a natural number or is a positive integer, right? So the answer that I have got, this answer should be a positive integer, right? Now, this is already an integer. What does that mean? this part should also be an integer. So if that part is an integer, we can take a p common, and when we take a p common, we get p to the power k minus 1, something p to the power k minus 2, and so on till this last something, whole divided by k factorial, right? And of course, we have minus 1 to the power k already sitting over here. Now, p is already a prime number, hence it is an integer, and it is multiplied with something, right? So if this whole thing is an integer, that means that something must also be an integer, because integer multiplied with an integer can only give you an integer. That means I can write this as p times lambda plus minus 1 to the power k, where lambda is some integer. Let's denote it with capital Z. So what does this mean? It means that this number p minus 1 ck can be expressed as p lambda plus minus 1 to the power k. So obviously, what will be the remainder when I divide this number by p? You'll say the remainder that I will get is going to be nothing but minus 1 to the power k. Right? So this solves the problem. So now coming to the question that I had asked, what is the remainder when 88C44 is divided by 89? So the answer to this question is going to be minus 1 to the power 44, and that's nothing but 1. So this solves the question. तो कैसा लगा ये मेथड? अब चलो देखते हैं ओलंपियाड वाला मेथड, जिसको हम कहेंगे द मॉड्यूलर अरिथमेटिक मेथड. Now let us look into the modular arithmetic way of solving the question. So let's take up the modular arithmetic method. The modular arithmetic method. So now we'll start with our old expression that we had already got, which is p minus 1 ck. So it was nothing but p minus 1, p minus 2, p minus 3, all the way till p minus k whole divided by k factorial, right? So now if I ask you a simple question, what is the remainder when p minus 1 is divided by p? That is what we call in terms of modular arithmetic as this. So p minus 1 will leave a remainder of minus 1 when divided by p. So in the language of modular arithmetic, we say p minus 1 is congruent to minus 1 modulo p. So those who are already aware of modular arithmetic, this is a very simple thing to understand. In the same way, I can say p minus 2 will be congruent to minus 2 modulo p. And if I continue this trend, then p minus k will be congruent to minus k modulo p, right? Now, modular arithmetic property says that if you multiply all the left-hand sides, even the right-hand sides will get multiplied. So as per modular arithmetic property, we can say p minus 1, p minus 2, all the way till p minus k is congruent to minus 1, minus 2, minus 3, all the way till minus k, which is nothing but minus 1 to the power k factorial modulo p. Right? So this is coming from the modular arithmetic property. Now, if I divide both sides by k factorial, so let's say if I divide both sides by k factorial, so let us write that down. If I divide both sides with k factorial, so the modular property says then this will be equal to minus 1 to the power k factorial divided by k factorial. So k factorial gets cancelled off. Modulo p divided by GCD, the SCF of p and k factorial, right? So this is again a division property of modular arithmetic. But what is the GCD of p and k factorial? Of course, you will say it's going to be 1 because p is a prime number here. So this term that you see is going to be a 1. Why? Because p is a prime number. P is a prime number, right? So it brings me to this result that p minus 1, p minus 2, all the way till p minus k by k factorial is congruent to minus 1 to the power k modulo p, right? In other words, the remainder that you get when you divide that expression p minus 1 ck by p is minus 1 to the power k. So this answers the question again. So remainder is minus 1 to the power k. So what is the remainder when 88C44 is divided by 89? The answer is minus 1 to the power 44, which is going to be a 1. Right? So this is another way to solve the same problem. तो दोस्तों ये दोनों ही मेथड आपको आने चाहिए, क्योंकि कई बार जेई एस्पिरेंट्स और जेई फैकल्टी मेंबर्स को मॉड्यूलर अरिथमेटिक मेथड के बारे में पता नहीं होता, जिसके कारण उनको ऐसे प्रॉब्लम सॉल्व करने में बहुत ज्यादा वक्त लगता है, thereby decreasing their chances of selection in IIT. आशा करता हूं दोस्तों कि आपको ये वीडियो पसंद आया होगा. प्लीज लाइक, सब्सक्राइब एंड शेयर इट विथ योर जेई प्रेप फ्रेंड्स. Adios.